Okay, section 6.2, measures of spread. So this is now the topics of range, quartiles, and percentiles. So, what is a measure of spread? Well, it indicates how closely a set of data clusters around its center. Center meaning the mean, median, or mode. But like how close is your set of data to the center? Whereas previously we studied measures of central tendency, which are measuring the center, but it's now measuring how the data clusters around its center. It could be how spread apart, far apart. It could be close to the center. This is what the measures of spread will tell you. Okay. One of those measures are is the range. It's a calculation of the difference between the highest and the lowest value in a data set. But a range doesn't tell us how the data are spread out. It just gives you the absolute extreme ends. Okay. Percentiles is the difference of all the data in a set that are less than or equal to a specific data value. So k% of the data are less than or equal to the kth percentile, or p of k. Okay? And before you even do any percentiles, you have to make sure your data set is sorted from lowest to highest. So there are a couple of measures here. One is the percentile rank. And this calculates the value in a data set that falls in a given percentile. And it's given by this little formula here, R equals P divided by 100 times N plus 1 in brackets. Okay, and P is my percentile, N is the size of the population, or the size of your data set, and R is the whole number rank of the data point. And if R is not a whole number, you round R down. Percentiles are what calculates the percent of data that is less than or equal to a given value. So if I'm told, if I'm looking for a percentile, I'm looking at this, again, N, size of the population. L is the number of data less than the data value. So I'm looking at, let's say, well, what is a percentile of the number 54 in your data set? Then you look at all the numbers left of 54, that would be your L. And you count all the numbers that are exactly 54, that would be your E. Okay, so if that is in the case of if 54 or whatever number you're dealing with repeats, right? Okay, so let's look at some examples on how to apply percentiles here. So example number 1, the list below shows the rank marks from least to greatest for 25 students on a recent test out of 40. Calculate the 80th percentile. So here we're asked for a rank, okay, the 80th percentile. So right here I'm going to highlight this as the rank. Okay, so I'm looking for a rank. I'm going to use this formula here. It starts with R. So R equals P over 100 times N plus 1. Okay, and here P is 80 because it is the 80th percentile. And the number of values in my data set is 25. I have 25 student marks. So if I take these values and I plug them into my formula here, I will get 80 divided by 100 times 25 plus 1. And when I simplify that, 80 divided by 100 is 0.8, and 25 plus 1 is 26. When I multiply 0.8 times 26, I get 20.8. So you see here, this 20.8 stands for the rank. That means the 20.8th number is the number in my data set that will represent the 80th percentile. But we don't like the decimals. We have to round to a whole number. And we always round down when we do these kinds of problems. So we round it to 20th. Okay, and the reason why we don't round up, because if 20.8 represents the 80th percentile, then 21, the 21st number, will not be the 80th percent. It will be something higher than 80%. So we always round down to guarantee that we have the 80th percent. So here, just make a note that we always round down. Okay, so when we do that, it says that this says to us that the 80th percentile is the average. Okay, so if we had to round down, it means if the 20th number isn't exactly the 80th percentile, it might be like 78%, right? So if we want the 80th percent, it's going to be a number between the 20th and the 21st number. the 20th and the 21st ranked number. So the 80th percentile is going to be, well, the best way to estimate this is to take the midpoint or the average. It's the average between the 20th and the 21st. Data point. Okay, so in this case, what is our 20th and 21st data point? So, I mean, if you look through this list, you have 5, 10, 15, 20, 21, 22, 20, 21. Oh, am I reading this correctly? 5, 10, 15, 20. So 20th is a 34. Okay, and then the 21st is the 36. So these are my two values. So this is the 20th, and this is the 21st. So it's going to be the average of these two values, right? So it's going to be 34 plus 36 divided by 2, 35. Okay, so this means that, therefore, 80% of all my data values is less than 35. Okay, so I mean, this is a class mark. So marks 35 out of 40. So 35 out of 40 represents my 80th percentile. So anyone who's below 80 who is 80% or below of the class, in terms of, like, the score, is going to have a score that's less than 35. Okay. Part B, what percentile is a mark of 25? So here you're asked to find, well, here you're given the mark. What is that as a percentile? What is that what is your standing with the rest of the class, in other words? Okay. So we're going to use the other formula here, that percentile is equal to 100 times L plus 0.5 E, all divided by N, where here L is equal to 7. Okay, so where I get 7 from is, you have to go back to the table of values. So here's 20, 25. We have 3 of them here. So how many numbers are less than 25? 1, 2, 3, 4, 5, 6, and 7 over here. So 7 data values are less than 25. Okay, so L equals 7. And so I also pointed out that 25 repeats 3 times. So E is the number of times this value repeats, so it's 3. And N, again, is the number of data values in our set. So we have 25 data points. Plug this into our formula. So the percentile is going to equal 100. 7 plus 0.5 times 3, all divided by 25. On my next line, I get 100 times everything in brackets resolves to 8.5, and again dividing everything by 25. And when I carry out this math over here, my answer is going to be 34. So therefore, I can say 34% of all data is less than the score of 25 out of 40. Okay, so percentile, what percentile is a mark of 25? Well, 25 is the 34th percentile, meaning 34% of all the data is less than that score of 25. So basically 34% of your class has scored less than 25. So what percentile is a mark of 40? Same idea. Apply the formula one more time. So here we have 100 times. This time L is equal to 24. If you go back up and count the values, there are 24 values less than 40. Because there are 40 is the highest value, it is the 25th value. And E is equal to 1. There's only one occurrence of that number 40. And again, you have 25 data value, so N is 25. Plugging this into my formula, L plus 0.5 E divided by N. Plugging in my numbers, 100 times 24 plus 0.5 times 1, all divided by 25. And that will be 100. My bracket resolves to 24.5, and I divide by 25, and that is equal to 98. Okay, so if you're wondering, well, 40 is the last number here. Why isn't that just the 100th percentile, right? Well, it's not, because there's not 100 values here. It's the 98th percentile. So this means the mark of 40 is represents the 98th percentile of the class. That includes, so that means 98% of all the class marks or all the data is less than a mark of 40. So 98% of all data is less than a mark of 40. So this is what this calculation tells us. Okay, so it's percentile. Again, back to the definition of percentile. It is percent of all data in a set that are less than or equal to a specific data value. So we're saying here that our data, 98% of all the data here in this set, is less than a mark of 40. Right? And that 40 represents that last bit to carry it to the rest of the data set. Right? Okay, so quartiles. So quartiles is just a special kind of percentile, right? Quartiles is just it divides a set of ordered data into 4 groups with equal numbers of values. So it divides them into quarters. So the first quartile is the median or lower half of the data, also the 25th percentile. Second quartile is the 50th percentile, so that's the median of the entire data set. And the third quartile, which is the 75th percentile. Okay, so here you have your lowest data point, datum. Here you have your highest datum. And your quartiles are in between. So quartile number 2 represents your median, the median of the entire data set. And quartile number 1 is the first 25%, and quartile number 3 is your 75% percentile. So if the number of the data is even, take the midpoint between the two middle values as the median. If the number of data below the median is even, Q1 is the midpoint between the two middle values and then half of the data, and Q3 is determined also in a similar way to Q1. So basically just help you determine, follow the median rules. So median rules say, well, if you have an even number of data points, you have to take the midpoint between the two middle values. Same idea when you're dealing with the lower half. If you have an even number of values, take the two middle values, the midpoint. Interquartile range is another term we need to know. It is the range for the middle half of the data. So this from Q1 to Q3, the difference between Q1 and Q3, that's my interquartile range. And the semi-interquartile range is just one half of the interquartile range. Okay. And these two ranges are useful because they also indicate how closely the data are clustered around the median value, the 50% mark. So let's look at another example, example number 2. A random survey of people at a science fiction convention asked them how many times they have seen Star Wars. The results are shown below. Determine the median, the first and third quartiles, and the interquartile and semi-quartile ranges. What information do these measures provide? So these are a bunch of values from a survey, so how many times they have seen Star Wars. And if you notice that this is not in any ordered list, you have to make them in order, so you have to do a little bit of sorting. Put them in place order. So if you put this in order first, pause the video, put them in order yourselves first, and I'll put them myself here next. And if you want, you can pause again just to make sure your values are correct. So here are the values. 1, 2, 2, 3, 3, 3, 4, 4, 5, 5, 6, 7, 8, 9, 10, 10, 12, 15, 16, and 30. Okay, so often it's easiest to find the median value, which is your second quartile first. Okay, so quartile number 2 is equal to the 10th plus 11th values divided by 2. It's the midpoint between those two values because we have how many points do we have? You can count how many values we have here. 4, 8, 12, 16, 20. You have 20 values, which is an even number, and that means you have to look at the 10th and 11th values, which are 5 and 6. So I'm going to take those two values, add them together, and divide by 2, and I'll get my median value, which is 5.5. That's my second quartile. Okay, so this says that 50% of those surveyed saw Star Wars 5.5 times or less. And you can also say, and 50% saw it 5.5 times or more. Okay, so that's the significance behind the second quartile. So here I can also mark it on my table here. So my second quartile falls right here, quartile number 2. Okay, so let's look at our first quartile now. So let's count how many values are below quartile 2. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, again, I have an even number of values below the second quartile. Okay, so that if I treat this as a data set, I have to take the two middle values. Even though I use this number as part of my median or quartile number 2 calculation, I still include it as part of the data set when I consider the first quartile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm taking the middle values between these two values, the fifth and the sixth value. So quartile 1 is equal to 5th plus 6th divided by 2. And since both of them are 3, it won't really change anything. 3 plus 3 divided by 2 is still equal to 3. So I can just simply indicate my quartile number 1 being right here, and quartile number 1 is equal to 3. So I can make a note of 3, and I forgot that I can write here 5.5. Okay, so let's continue on. Let me just change the ink back, and let's go find quartile number 3. So quartile number 3 has the same thing. We have 10 data values. So looking at the middle point, midpoint between the average of the two values here, because of the even number of values. Here's my quartile number 3, which is equal to 10, because 10 plus 10 divided by 2. Let me just say here that quartile 3 is the 15th plus 16th value divided by 2. This is just 10 plus 10 divided by 2, which is again just 10. Okay, so quartile 1 and quartile 3, what do they tell us? Let's make a quick note here. Quartile 1 and quartile 3 says half of those surveyed have seen, when I say half, by the way, I mean like from quartile 1 to quartile 3, this represents half of your population, because each of these quartiles is 25%, so 25% over here, plus 25% over here, so 50% make up this interquartile range here. So I'm saying half. So half of those surveyed have seen Star Wars between 3 and 10 times. 3 and 10 come from the fact that the lower end of my quartile, first quartile, and my upper end of my inner quartile range is 3 and 10. So my inner quartile range, just one more time to reiterate, it's the difference between Q3 minus Q1, which is just 10 minus 3, and that's 7. So the range of this interquartile range is 7. What about the semi? Well, you just take the interquartile range divided by 2. So 7 divided by 2 is 3.5. Okay, and so again, what's the point of this? Well, this shows how the center half of the data is spread around the median. And our last concept here in this section is the box and whisker plot. So this is a plot that we used to graphically illustrate the measurements represented in the quartiles. So Once you calculate your quartiles, you can create a nice graphic here that will show the range of the data, the position of the 3 quartile values, illustrated by these vertical lines, and the length of the interquartile range. So if most of your data is going to be clustered around the median, your box is going to be pretty small. The range of data below the Q1, so how many data points are between in the bottom 25% percentile, and how many data above Q3, how many data are in the upper 25 percentile. Okay. So you can also modify your box and whisker plot if your data contains outliers. So usually at any point that is 1.5 times the box length away from the box is classified as an outlier. So what does that mean? 1.5 times the box length. So what's your box length? It's going to be your IQR. And that's more than 1.5 times, so you have these outliers out here. So everything as is in the standard box and whisker plot is still the same thing, but the outlier data will be marked as individual points rather than including them as part of the whiskers. So again, using the Star Wars survey data and calculations from example 2, create a suitable box plot. So let's create our box plot here. We already have our values, so our median 5.5, Q1 you said was 3, Q3 is 10, IQR 7, semi-IQR is 3.5. And outlier check, is any of our data less than Q1 minus 1.5 times the entire box length, the interquartile range. So we're looking at Q1 minus 1.5 times the IQR. So if you take Q1, 3, Q1 is 3, right? So 3 minus 1.5 times 7. So it's 3 minus 10.5, which is equal to negative 7.5. So because it's a negative value, well, no, there are no outliers. So therefore, no outliers on the left. Okay. What about outliers on the right? Well, if you took quartile 3, you add 1.5 times the range of the box plot, the interquartile range. Let's see what we get. So quartile 3 is 10. I add 1.5 times the interquartile range, which is 7. And I get 10 plus 10.5, which is equal to 20.5. So therefore, any values beyond 20.5 would be considered an outlier. Okay, so beyond 20.5, are there any beyond 20.5? We do 30, right? It seems kind of irregular, even if without doing the calculations. It's kind of irregular that you'd have someone watch Star Wars 30 times and compare the rest of your data here, but nowhere is even that close. So I'm going to say here, therefore, 30 is an outlier. Okay, so I'm going to plot my 30 out here and as a single point, and my quartile 2 is at 5.5, so it's going to be somewhere, let's see, let's draw it like this. Okay, somewhere right there, 5.5, and my quartile 1 is at 3, or so right about there, and quartile 1 is at 3, and quartile 3 is at 10, so here's quartile 3. I'm just going to put some points here like this, create your box. And I'm going to label quartile 2 as being over here, quartile 3 over here, and quartile 1 over here. Now I need to draw my whiskers. So my lowest data value is 1. So I'm looking at the 1 over here. It's the lowest point. So at 1, I'm going to draw a point, create a whisker there. The highest value, with the exception of a 30, is going to be 16. So 16 over here is the next highest number. So draw my whisker all the way there. Right? If you notice, yeah, if I didn't do the modified box and whisker plot, my whisker would extend really far out there. And it kind of suggests that, well, yeah, 25% of your data is this line here, where in fact it should only really be this line, and you have the one outlier out there. So that's how you can create a box and whisker, or modified box and whisker plot with the outliers lying outside. So that is the end of my Star Wars example. Keep calm and may the Force be with you.